When you're solving trigonometric equations, you're generally solving for angles. And as we already know, when you write some statement, let's say sine of theta equals a half, we know that sine of 30 degrees equals a half, but we also know from looking at the sine curve, which looks something like this and goes on and on forever in both directions, that there's lots of answers for sine of something equals half. There'll be answers all the way along. And so, because we have this infinite range of answers for what theta could be, generally in questions like this, they'll give you a domain. They'll tell you where to look, and that narrows down your answer. Now, although you're looking for multiple solutions, you need to know which quadrants those solutions are going to sit in. So the clues that you've got is you look out for whether this is positive or negative here, because that will tell you what quadrant it's in, and you combine that with the domain that you've been given, and that will tell you the quadrants. And it's something you should write down first up before you start solving your equation. Now, this last point might seem a little confusing, but let me explain. You need to use the positive version of the ratio that you've been given. Now, by ratio, I mean a fraction like this, to find the related acute angle. All right, now, sine of theta equals a half. So if we use this one as an example, we'd say, all right, I know that sine of 30 degrees equals a half, but I also know that sine is positive when it's in the second quadrant as well, first and second quadrant. Think all stations 2 central. So here, if I was told that x had to be between 0 and 360 degrees, I would solve this one by saying, all right, I know that theta can be 30 degrees, but it can also be 150 degrees, because when we're looking at the second quadrant, we need to do 180 minus whatever the related acute angle was to get other answers, okay? And at this point, I'd be finished. Now, when I did this one, it was quite simple because I thought sine of something equals a half. Now, I know that one off the top of my head because it's an exact one. Sine of 30 degrees equals a half. But if it said sine of theta equals 2/3 or something like that, I'd type into my calculator inverse sine 2/3, and that would give me the angle. And I might have to round it off to the nearest degree or the nearest minute, whatever I've been asked. Now, because this one was positive, I was straight away thinking what quadrants I was in, but that first quadrant answer came to me straight away, didn't it? Because it's sort of sitting there looking at me. Now, let's have a look at this one as an example. It's got a negative in it. So we've given the domain, x must be between 0 and 360. So it's in the first, second, third or quadrant from that. But we're told that cos of x equals a negative. Now, using your all stations 2 central, you know that cos is positive here and here, so it's negative over in the second and the third quadrant. So you might like to write that down straight away, second or third quadrant. Now, this little clue here, this negative, that's what's given us that understanding that it's in the second or third quadrant. Now that it's given us that, we can pretty much ignore it and just think, all right, what's the related acute angle that would be positive √3 on 2? Now, why am I thinking that way? Well, because if I'm looking for a related acute angle, then I'm looking in the first quadrant, aren't I? Because acute angles all sit there. And this, A for all, tells me that sine, cos and tan are all positive here. So if I want to find the related acute angle for this question, then what I want to ask myself is cos of something is √3 on 2. What is that something? Okay, now this is an exact one, which I know off the top of my head because I've memorised my exact values. But if I wasn't sure, I could always type into my calculator and do, to find x, you would do inverse cosine, inverse cos of √3 on 2. All right? Now, remember, the cos of 30 degrees gives me √3 on 2. So my related angle is 30 degrees. Now, if you like to, you can write it down like that. You can write down the quadrant, you can write down the related angle. What you're probably going to find is that after a while, you tend to just hold that in your head and remember it. And as you then go to write down what x could be, obviously x can't be 30 degrees. We've found the 30 by doing inverse cos of √3 on 2, but you can't just blindly go writing that down because we've already said the answer must be in the second or third quadrant using this 30 degree related angle. Now remember that with your quadrants, when we're in the second or the third quadrant, we're doing either 180 minus theta or 180 plus theta. Okay, so our two answers would be 180 minus 30, which is 150 degrees, or 180 plus 30, which will give me 210 degrees. And those are my two solutions. Now, this example has a bit of a trick to it in that the domain that we've been given has negative numbers in it. It's still 4 quadrants wide, or 360 degrees wide, but it goes from minus 180 to positive 180 rather than from 0 to 360. So as we're thinking about what quadrant our answer for theta could be in, we need to be aware that there's multiple answers for the same ray. Now let me just remind you of what I mean here. If I've got an angle, let's say I've drawn a ray here in the 4th quadrant, and let's say this angle is 40 degrees, then I can either get to this spot by starting here at 0 and going all the way around in a positive direction, and I'd be going 320 degrees, or I could get there from starting here and going in the negative direction, minus 40 degrees. Okay. Now, what that means is that if I find the sine or the cos or the tan of 320 degrees, it's going to be the same as the sine, cos or tan of this other related angle. Okay, it's just another name for the same thing. So what I need to be sure of is that the answers that I come up with fit within this domain. So if I've got an answer in the 3rd or the 4th quadrant, I don't want an answer that's bigger than 180 and less than 360 degrees. I'm going to have to find it by going backwards a certain number of degrees. All right, let's have a look at how to do it. So first I've got to look for clues. I've got 4 quadrants in my answer, but here it says that tangent of theta equals -4. Now for tan to be negative, think through your all stations to central, jot it down if you need to, and think tan is positive here and here, so it's negative here and here in the 2nd and 4th quadrants. Jot it down, 2nd and 4th quadrant. Only takes a second to write it, and then you know what you're going for. Okay, so if you're looking for your related angle, so you can even write down related theta. Now, your related theta is going to be positive, okay? Why is it positive? Because your related angle is acute, okay? And in the 1st quadrant, where everything is acute, sine, cos and tan are all positive there. So the tangent of an acute angle is going to be +4, not -4. So next step is you think, all right, we're going to need our calculator for this because it's not an exact one that we know. So the inverse tan of 4, notice I'm not putting -4 in here, I'm just putting 4 because I'm finding a related positive angle. I type in inverse tan of 4, and to the nearest degree, theta is 76 degrees. Now if you've rounded it off, say what you've rounded it to, nearest degree. All right, now I need to convert this, and this is an angle of 76 degrees in the 1st quadrant. I need to somehow get that over into the 2nd quadrant and down into the 4th quadrant so that it fits into this domain. Now, angles in the 2nd quadrant, remember, it's always got this symmetry. If that's 76, this is 76. So I need to do 180 minus 76, and that will give me my first answer. So that'll be 104 degrees. Now, every answer you write down, check if it's in your domain and it's an acceptable answer, and that's fine. And now to get it into the 4th quadrant, I need to just bounce it down here, 76 degrees, in the negative direction. So to do that, I've got just -76 degrees. And then again, check that that's within the range, the domain, and it is. So those are my two answers. You can write or in between, or just a comma is fine. It's kind of nicer probably to put the smaller answer first, but I'm not too fussed about it and I wouldn't bother rewriting it. And so this answer here is not our actual answer, it's really just the related. Here and here we're finding the related angle, and here we're answering the question.